Today we're going to start on solving a formula for a specific variable. All right, so if you remember, let's say if you have 3x equals 1. And you want it to solve for x. All you have to do is divide both sides by 3. Anything divided by itself is just going to be 1. Okay, so you know that x would equal 1/3. Okay. So let's say instead of 3x equals 1, you wanted to have Rx equals 1. And you still wanted to solve for x. Okay, so here you do the exact same thing. If you have r times x equals 1, same way you divide it here, both by 3, you divide both sides by r. Okay, so anything divided by itself, whether it's a number or a variable, doesn't matter at all. Anything divided by itself is going to equal 1. Okay, so that means x is equal to 1 over r. So it's the same process whether you have numbers or variables, it doesn't matter at all. Okay, so what if you had an example with no numbers at all? Let's say if you have m times x equals z, and you wanted to solve for x. Okay. Exact same process. M times x equals z, but in this case you divide both sides by m. So if you divide both sides by m, anything divided by itself is 1. So x would equal z over m. Okay, so whether you have numbers or variables, like I said, it's the exact same process. It doesn't change at all. Move that out a little bit. All right, so any questions on that one? All right, I'll leave that up for a few seconds. All right, so let's say, for example, if you have m minus 1 equals 3, and we wanted to solve for m. Okay, so we always know we have to do the opposite. So for m minus 1 equals 3, we add 1 to both sides, where those two cancel out. So m will equal 3 plus 1, which is 4. Okay, so same thing if we had, let's say, m minus r equals 3. And we wanted to solve for m. Okay, so if we had m minus r, clean that up a little bit. So m minus r equals 3. Here, where we added 1 to both sides, now we just add r to both sides. Okay, and again, those two cancel each other out. So we have m equals, now here you can add 3 and 1. Here you can't add 3 and r if you don't know what r is. So you just leave it as 3 plus r. You only combine them if you can. Okay, does that make sense? Yeah. All right. Okay, so we solve for m there. Okay, so what if we had just all variables? M minus r equals b, and we want to solve for m. Okay, we do the exact same thing. Okay, so we go ahead and just add r to both sides. Okay, these two are going to cancel out. So you have m equals, you can't combine two different variables, so you just leave it as b plus r. Okay, so you only combine them if you can. If you can't combine them, you leave them exactly the same. All right, any questions on any of those? All right, I'll leave that up there for a second. So what if we had the example 3x plus 4 equals 19. And again, we want to solve for x. Okay, so usually our first step is we want to get the x term by itself. So for 3x plus 4 equals 19, we subtract 4 from both sides. Okay, so these two cancel each other out. So you're left with 3x equals 19 minus 4, which is 15. Okay. Then we divide both sides by 3. And anything divided by itself is just 1. So we know that our x would equal 15 divided by 3, which is 5. Okay. Which works out when you have one variable and a bunch of numbers. Okay. So what if you have 3x plus n equals 19, and you want to solve for x? Thank you. Okay. So just like before, 3x plus n equals 19, we want to do the x term by itself. So you subtract n from both sides. 4, we subtracted 4. This time, we get rid of the n, where those two cancel each other out. Okay, so that leaves you with 3x equals, we could combine 19 minus 4. We can't do it with 19 minus n, so we just leave it as 19 minus n. Oh, clean that up a little bit. Okay, so now we just divide both sides by 3. So our 3x equals 19 minus n. Divide both sides of the equal sign by 3. Okay, so anything divided by itself, as always, is always going to give you 1. Okay, so that means that x is equal to 19 minus n over 3. Okay. Now you can also get that denominator and separate it. Yes?
I was about to say, what happens if you divide by 3 before you minus the n?
Oh, before you minus the n? Well, you couldn't do that because you could only divide that. Well, you could do it for both sides, and I'll show you in a second. Let me see. So that gives you 19 over 3 minus n over 3. Okay, so either one of those. But if you did the divide by 3 first, let me move that over. So if you have 3x plus n equals 19, if you want to get the x by itself, you have to divide everything by 3. Okay, so you could have done it that way, where anything divided by itself is 1. So you have x equals n over 3. Oh, x plus n over 3 equals 19 over 3. Oh, let me move this up a little bit. And then you just subtract n over 3 on both sides.
Yeah, I was thinking because I didn't know you gotta divide by the 3 by the n2. What you do on one side, you do on the other side.
Yep, you do. You have to do it to everything. Yep, the whole thing. All right, so if we subtract n over 3, we have x equals 19 over 3 minus n over 3. Okay, so it works out either way. All right, any other questions on this one? All right, so instead of, let's say, 3x plus n equals 19, I'll leave that up in case anyone's still writing. Looks like everyone's done writing. Oh, let's see a few more. All right. So let's say we transition into mx plus n equals 19. Again, solve for x. Okay, so you can see the rules are the exact same either way. Mx plus n equals 19. Subtract n from both sides, where those two will cancel each other out. So you have m times x equals 19 minus n. And then we divide everything by m, just to get x by itself. So if we divide everything by m, divide each term by m. Okay. Anything divided by itself will always give us 1. So you have x equals 19 over m minus n over m.
What if you just say if you did 19 minus n over m?
Oh yeah, if you wanted to write it like that, you could. So you have 19 minus n over m, if you want to combine your denominators. All right, any questions on that one? All right, so let's say if we got rid of all numbers completely. So we have mx plus n equals b. And we want to solve for x. Okay, so we do the exact same thing we do up here. We want to get our x term by itself, so we subtract n from both sides. Okay, n minus n, those two will cancel each other out. So you have m times x equals b minus n. Since you have two different variables, we don't know if they're equal or not, so we just leave them as b minus n. And just like we did up here, divide everything by m. Okay, so if we divide each term by m, okay, anything divided by itself always give us 1. So you have x equals b over m minus n over m, or you can make it b minus n over m. Okay, so these are the situations where you'll have absolutely 0 numbers, and they'll ask you to solve for a variable. All right, any questions on this one? All right, I'll leave that up there for a second. All right, so what if we had area equals 1/2 the base times the height, which is the area of a triangle. And we want to solve for h. Okay, so remember, the best way to solve an equation with a fraction is to get rid of the fraction. So if you have 1/2, you want to multiply both sides by the least common denominator. So you multiply both sides by 2. So a equals 1/2 b times h. Multiply each side by the least common denominator, which is 2. Okay, so that means you'll end up with 2 times a equals 2 times 1/2. Well, I could have put the 2 in parentheses. 2 times 1/2 b times h. Okay, so we know there that 2 times 1/2, that's just 2 over 1 times 1 over 2. It's 2 over 2, which is 1. So really the 2 and the 1/2 cancel each other out. So those two cancel out. That means we have 2a equals b times h. Okay. So for solving for h, if we had 3 times h, we divide both sides by 3. But since we have b times h, we just divide both sides by b. Okay, so that would give us 2a equals b times h, but we divide both sides by b, where we know that b divided by b is just 1. So these two cancel each other out. So you're left with 2a divided by b is equal to h. All right, so any questions on that one? All right. I'll leave that up for a second. All right, so let's say for our next example, let's say if you wanted to solve A equals 1/2 B times H for B when A is equal to 126 and H is equal to 18. Alright, so if we have A equals 1/2 B times H, and we know A is 126 and H is 18, replace A with 126, so you have 126 equals 1/2. B is just B, so that doesn't go anywhere. H is 18, so B times 18. Alright. Now with this one, you could multiply each side by the denominator, which is 2. But here you have a 2 and an 18, both on the same side. So that means 1/2 times B times 18. Since you're multiplying, you can move those around. That's like saying 2 times 3 is the same as 3 times 2. You can shuffle them around. So this one, you can make it 1/2 times 18 times B. So 126 equals 1/2 times 18 times B. Okay. And I move them next to each other because we know that 1/2 times 18, we can rewrite that as 1/2 times 18 over 1, which 1 times 18 is 18. 2 times 1 is 2, which gives you 9. Now you could have done that without moving them around, but sometimes when they're next to each other, it's just a little easier to visualize. Okay, so these two actually combine to give you 9. So you have 126 equals 9B. So now we just divide both sides by 9. So you have 126 equals 9B. So we divide both sides by 9. Of course, anything divided by itself is 1. So 126 over 9. Actually, we can just go ahead and solve that. So now we have B. And 126 over 9. You can just rewrite that as 126 divided by 9. Okay, so 9 goes into 12 once. 9 times 1 is 9. 12 minus 9 is 3. Bring down a 6. 9 goes into 36 4 times. 9 times 4 is 36. 0. So B is equal to 14. All right, so any questions on that one? All right, I'll leave that one up. Looks like everyone's done writing. Okay, so let's say if we have, for example, if we wanted to solve 5x plus 2y equals 19. Excuse me. Okay, so just like before, our 5x plus 2y equals 19. Since we're solving for y, we want to get this term by itself. So we subtract 5x from both sides. Okay, these two cancel each other out. So you have 2y equals 19 minus 5x. And just like before, now we divide everything by 2. And anything divided by itself is just 1. So that leaves us with y equals 19 over 2 minus that 5 over 2. We could bring that out to the front if we want to, because 5x over 2 is the same as saying 5 times x over 2, which is the same as 5 over 2 times x over 1, which is the same as 5 over 2 times x. So that 5 over 2 can be brought right out to the front times x. Okay. Now you could also, if you wanted to, switch those two terms up, as long as that sign comes with it. So you can make y equals negative 5 over 2x plus 19 over 2. Okay, so either one of these would be correct, but when we start talking about graphing and slopes and formulas and all of those, this would be the method that we'd use. We want to have the x term first. So either one of these would be correct. Yes?
So the 19 over 2 minus 5x over 2 wouldn't be correct?
It could be, but you always want to bring the coefficient out to the front.
Okay.
So that's why you want your numerical value out to the front and the variable sitting on the side by itself. Yes?
At the beginning, you said solve for x, and you solve for y.
Yes. Yep, I didn't put that up there. Thank you. All right, any other questions? Yes.
Could you just write it as 5x, or negative 5x plus 19 over 2, or would that not be correct?
It would be correct, but when we start talking into y-intercepts and everything else, then that form would be able to give us all of that.
Okay.
So it's correct, but we'd be able to get more out of it if it's written this way. All right. All right. Any other questions? All right. Anyone still writing? Okay. So let's say, for example, if we want to solve circumference equals pi times the diameter, and we want to solve for pi. Okay. That one's the same way as if we had 3x equals 1. We're solving for pi, so we divide both sides by d. Oh, clean that up a little bit there. Okay, anything divided by itself is just 1. So that gives us pi equals circumference divided by d. Okay. Or let's say if we had the